So in this problem we have been given two numbers. One is 3.14 raised to the power pi and another is pi raised to the power 3.14. And then we have to find which one is greater. Basically 3.14 is an approximate value of pi. Pi is an irrational number and the value of pi is 3.14159265359, something like this. So this keep goes on. But if you consider only 3 digit, approximate value of 3.14, that is the second number I have, that is 3.14. So now to answer this question, which one is greater, either this one or that one, we will take help of calculus. So let us say, we say x1 is equals to 3.14 and x2 is equals to pi. Clearly, you can see that x2 is this one and x1 is this one. So x2 in this case is greater than x1. Now we will consider a function. So let us consider this function. So consider why we are considering this function. You will understand towards the end of this video. So let us consider this function fx log x divided by x. Now we want to investigate this function. Where is the maxima and what is the nature of this function? So to find the maximum point, we have to first differentiate. So I will use the rule for differentiation, that is differentiation of u by v is equals to v times differentiation of u. Let us write u dash. U dash denotes differentiation of u minus u times differentiation of v divided by v square. So we will use this rule to differentiate this function. So function is ln x by x. So if I differentiate, let us call this f dash x. So we have in this case b is equals to x and u is equals to ln x. So in the first step, I have to keep b as it is and differentiation of ln x is 1 by x minus I have to keep numerator as it is and differentiation of x is 1 and this divided by a square of denominator, that is x square. Now so f dash x will be, so this will be simply 1 minus ln x divided by x square. Now to find the critical point, that is where the maximum will occur or whether the minimum will occur, we have to equate it to 0, that is f dash x equals to 0. This means 1 minus log x divided by x square is equals to 0. This means log x is equals to 1. And in this case base is e, so x will be e raised to the power 1, so this means simply e. And you may remember the approximate value of e is 2.71 something something something. So this is the value for x. This means at this point either maxima occur or minima occur. Now to find whether this maxima or minima, we have to find double differentiation, that is f double dash x. So this means I have to differentiate this term once again. So if I differentiate this term once again using the same rule, that is this rule, then we can find the second differentiation. So in this case f double dash x will be, so first I have to leave the denominator, that is x square, and differentiate the numerator. So differentiation of 1 is 0 minus differentiation of ln x is 1 by x minus I have to leave the numerator now, 1 minus ln x, and differentiate the denominator. So x square, differentiation of x square is 2x, and this divided by x square and then whole square, so this will become x4. So now if I simplify, this will be x minus x, and then this will be minus 2x, and this is minus minus plus 2x times ln x divided by x4. Now let us find what is the value of f double dash x at x is equals to e. This means I have to plug everywhere x is equals to e. So this is minus 2x and minus x, that is minus 3x. So this is simply minus 3e plus 2 times e ln e and divided by e raised to the power 4. So you can see here this f dash x will be minus 3e plus, and this is log of e on the base of e is 1. So this will be 2e divided by e4. So this is basically minus 3e and plus 2e, that is minus e divided by e4, that is minus 1 by eq. So this is a negative number. So if f double dash x is negative, this means at this critical point you have a maxima. So now I know that at x equals to e, there is a maxima. So there is a maximum. So now if you plot the graph of this function, how it will look. So you have this function is something like this. I'm not plotting the whole graph. Exact graph you can plot, and I have also shown in one of the video. So at x equals to e, so let us consider this point, that is x is equals to e, that is 2.71. You have maxima, somewhere here is the maxima, and then both sides this function will decrease. Basically this function goes like this. This function goes like this. So for the time being, at this point you have maxima. And let us say you have two values, that is x1 and x2. So if you remember, we said x1 is equals to 3.14 and x2 is equals to pi. x2 is equals to pi, basically x2 is greater than x1. So I can show these two numbers. So x1 will come somewhere here and x2 will come somewhere here. So this is the value of function at x1. So this is basically fx1. So this value is fx1. And this value at x equals to 2. So this is fx2. Now see, in this region, this function is a decreasing function. So decreasing function. This means now I can use the property of decreasing function, that is if x2 is greater than x1, since the function is decreasing, then fx2 will be less than fx1. So this is the property of a decreasing function, that if x2 is greater than x1, then fx2 will be less than fx1. Now what is function? Function is simply fx is equals to ln x by x. So now I can use this result. So I will have ln x2. So this thing, I can simply put the value of x2 and x1. So I can say ln x2 by x2 is less than ln x1 by x1. Now x2 is what? x2 is pi. So ln pi and this divided by pi, and this is of course base is e, is less than ln 3.14 divided by 3.14. So we can further rewrite, that is if I multiply this side, so 3.14 ln pi is less than pi times ln 3.14. Now rule of log, if something is in the product, then this becomes power. So this means there is a rule in the log, that is log of a raised to the power m is equals to m log a. M log a. So if something is in the power, it becomes product. So if I use that rule, or something is in the product, it becomes power. So this means now I can write ln pi raised to the power 3.14, and this is less than log of, this is ln I am writing, so ln 3.14 raised to the power pi. Now the log function is an increasing function. So here I have a log function. Log function is an increasing function. This means if x1 is greater than x2, then fx1 will also be greater than fx2. In other words, if fx1 is less than fx2, then x1 will be less than x2. So if I use that property, I can say pi raised to the power 3.14 is less than 3.14 raised to the power pi. And this I am saying because log is a increasing function. Increasing function. So this number, that is 3.14 raised to the power of pi, is a greater number. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like to this video and subscribe to my channel. And I will see you in the next video. Thank you.